guys, today it's time for step 2. On the first video we discussed about how someone can scrape data from certain sites, process it, and prepare it for further analysis by using machine learning models. So here are what I do is I use Excel files, I scrape data, and we had an example here from the Allsvenskan League. So the final sheet, the final table that I use, it's this one. So I have date, time, league, home, the scores, a column for away matches. So all those should be metadata. That means I don't want to process them. I just want to carry them so I would see the results. Then I will use this column as a target column. So this will be my target feature. And then I will have all those columns that will be my features. So I need to analyze the features by using by judging which machine learning model will score best. I need to find correlations between the numbers, and the previous data will be my training data, and this data over here will be the data that I want to analyze and come up with results. So I'm not going to show you code, but I will show you another software which is like graphical code, just for you to understand the concept. It's not going to be about numbers. It's not going to be about writing code and do the exact procedure that I follow, but it's going to be good for you to understand the concept of how we do it. And then you can probably search online or have tutorials and be able to come up with your own betting model. So I can start with this software over here. It's called Orange, and it's a graphical way of writing code or understanding how machine learning and AI models work. So what we do, we upload the file, or you can write code that you take the file as a table. So I say that I have this Excel file, this data Allsvenskan, the one that we use, and I'm going to sit2. So sit2 is this one over here. So it will understand this, it will take it as a table. So the table has certain name for each column, and if we go here, you see that, okay, it understands time, league, home, score 1, 2. So what I need to do here, I need to tell the software if the data in each column will be metadata. That means I just carry it without using it. If I will skip it, I don't want to have it at all. Or if it will be my target column, so the column that it will train itself and will give me results. And then what will be the features? What are the numbers that we will use to find correlations with the target column? The first thing that I need to do is I need to distinguish if it's categorical or numerical value. When we input data, we need to judge it. The software can understand by itself, but sometimes it doesn't understand, or it's not what we want to do, so we need to just change it. So what I've done up to now is that the time, league, home, those are data that I just want to carry. So I just the role of it is like metadata. Then I have my result here that it's my target data, and it can be away team to win, draw, or the home team to win. This is the column that I created, if you want to go to the previous video and understand what I did over here. And this is a categorical type. So it will not be linear by using numbers and find correlation between this number, but it will find correlations between the feature that are numerical values, and it will end up with A, D, or H. So it will be like a text that it will not be a number We don't try to find a number, but this is going to be a percentage of this specific category to happen. So, for example, it will tell us that the away team to win will have 75%, 20% for the draw, and 10% for the 5% for the home team to win. So this is how we do it. So this is how we input the features. We set our target feature, and then we need to rank them. So we need to see which feature is more important according to specific scoring methods. So the scoring methods that we can use in the machine learning models are those: information gain, Gini, ANOVA, squared, X, relief. So for each method, the software gives us how important this feature is for the final outcome. So we see that for this information gain, the home team, the home losses per match played are the most insignificant one. But also the home wins per match played is significant. Then the home points per game, it's also high enough. But this is, we try to rank the features that we have. So you can see that we have some features here that are insignificant. So shots per 90 minutes, it seems that it's significant. Goal against per 90 minutes for the away team, it's insignificant. The shots per 90 minutes for the home team, it is significant. So the significant ones are those. For each league, it may be different. For each match, it may be different. But this is how we do it. We have the features, we rank them, and then we try to see if we can predict if our machine learning model scores well with only 5, with 6, with 7. But here you can see that our machine learning model, we score the best if we use all those 6, 5, 8, 10, it depends. So this is how we rank the importance of our features. And the software gives a value to each feature. So this is the weight that the software can process later on. Then we need to process the data over here. First, we need to normalize them in order to compare them and find correlations. So we use any method. You can try and see which is best. We pick one of the scoring methods, the ones that we said before, the ranking methods. And then we pick the number of the features that give us the best score. So what we do, we have this pre-process that we want to do. And then we have all the machine learning models that we want to perform in a row. So we connect the data with every model. And then we try to find the score. So we want to train the software. So how do we train the software? Here are all the results. So we connect the data with a specific scoring method that we had. We normalize them. This is the scoring method. And then we try to find which combination. I mean, we can start with 8 features and see in which combination we have the biggest score. So what we care is the area under the curve. You can see it here. And then the classification accuracy. So you can see here right now that neural network has the second biggest area under the curve, and logistic regression has the first biggest. And the important here, classification accuracy, the logistic regression also has big, but also the SGD over here has also a big one. But we're interested in a combination of those two. So I would say that logistic regression right now scores the best. And the software also gives us a comparison between the models under the curve or let's say classification accuracy. So you can see that if we go to neural networks, so if we compare neural networks with K and N, neural network is better 90%. Neural network with classification tree, neural network is 94%. So if we compare it with logistic regression, you can see that logistic regression is better because it's only 0.002. It's less than 50%. So if we go to logistic regression here, and you compare it with neural networks, you see that logistic regression is 91% better than neural networks. For this specific case, for another league or for another combination of features, it may be better neural network for this phase, for this learning training data. We have those compared. So we follow the one that scores the best, and very important is the percentage that scores. So we saw right now that we checked all the models. Each machine learning model is a specific scientific method that you need to study thoroughly in order to be able to judge it. But for now, just for you to know the concept, this is how we have the data, that we have result data, target data, we have the features. We need to find correlations between the models. We find which model scores the best. You can see it over here. And then we see that logistic regression scores better. We can also see the results here, proportion of the predicted. So we go to logistic regression over here, and you see that this is the percentage. So out of the 65 actual results, 50% of it is correct, that were predicted away. 50% of those numbers that predicted draw succeeded, and then 58% of the matches that predicted home succeeded as well. But from the matches that were predicted away, 30% was a draw and 18% was home. So the red ones were lost, but those won. And the same thing, this is percentages, but we can see it also as numbers. So we trained in 216 results, and we had 33 correct ones that were predicted away, 20 mistakes, and 20 that were draw, and 12 that were home. The same thing for where we predicted a draw and where we predicted a home win. So we can see the actual results over there. And then we take the predictions, we find which model scores the best. I forgot to say that how does the model predict and how does the model train, and how accurate is this precision 45% that it says. It's very accurate because we say we can pick that how do we want to do the cross-validation. So we split the data, the training data that we have, in 10 parts, and then we use the 9 parts as training and 1 part as the target data. And this is, we use the 1/10 to predict and the 9/10 to train itself. And then we pick 9 other faults and we predict the other 10th, then other 9s and the other 10. So it does this 10 different times. Or we can do it 3, 5, we choose what we want to do. Depending on the size of our data, we can pick a different one. All this that I'm describing now is happening with coding. It can be done in 10 lines. It's very easy to do everything. But in order to understand the concept, this is the best way for you to think and see how it works. And then we can have other data. We use this training that we did over here. We have our accuracy, so we want to predict new outcomes. So what we do here? So let's see what our software does. Here is the result that we have. This is what happened at the end. And this is over here, each model, the prediction that each model gave us. So we see that this result was an away win. So the logistic regression gave us a home team to win by 40% over here, draw 23% and 37% the away team to win. This was a very close game, so the outcome could have been any. You can see here that naive bias tell us home team to win. Almost everything tells us the home team win, except the random forest over here and the ADA boost. So what it gives us percentage. Its machine learning model gives us percentages of an outcome. And then we judge if the outcome, or if the percentage, if it's 65, for example, percent, it says that it has 65% probability the outcome to be an away team to win. So this is what the software gives us. It gives us numbers, percentages of its outcome, and it gives us the outcome that scores the most. Then we compare it with the actual result and we find what will happen. So if we go a little bit under, this is used as training. All those are used as training. So here you can see that where there is question mark, we don't have a result. We don't have any match done yet. So the software still takes the statistical features, it calculates them, and it gives us percentage. So for this match over here, we see that the away team to win gives us 73% logistic regression, that we know that it scores the most. So I would go to this match over here. I would say, okay, the away team to win has 73%. And then you can figure out, we'll speak in later videos, how we can take those percentages and come up with actual picks. We need to compare them with odds and in reality decide what is the most profitable bet for us. So this is how it is. It's not very complicated to do it, but it's very complicated to understand and interpret it what's happening. In most cases, when we use AI and supervised methods, in reality we don't understand what's happening. We just judge which model scores best, or we just follow a certain model. We just see the score, if it's correct or not, and we don't care how we come up to this result. That's the complexity of the thing that's happening, and the important thing is for the future that AI can conquer the world. This is what we say. We will not know how it conquers the world. It will give us right results. It can go into anything, but this is the thing. This is the most difficult thing to do. But for now, we can use it to have our predictions, have the find out the accuracy, follow it, judge it, I don't know, for a month, 2 months, as long as you wish. And when you feel sure with your model, you can go on with your predictions and follow your betting method and go on with that. So that's it for now. If you have questions, you can actually spend some time and write in the comments. I will try to answer everything. This is just a very simple way of me explaining you how this works. If we are to go and explain exactly how I do with my models, um, it will take more time. I will probably do it in the future. Um, Probably show some code, explain you what every command means. But for now, I think you can start exploring this amazing world of machine learning and artificial intelligence by yourself. So good luck. I hope this tutorial was helpful enough, and I'm waiting for your comments and questions. Thank you, and don't forget to subscribe.